Now let's talk about Redux. Redux is sort of like Helm for JavaScript. And what do I mean by that? Well, it's based on this Elm idea of having all of the state information in a single data structure. And it's in a single immutable data structure. Now, unlike Elm, JavaScript won't guarantee the immutability since everything in Elm is immutable, including the state. Then Elm is not going to allow you to modify the state information directly. In JavaScript, that's more of a convention that you have to try to follow, although there are some packages that can try to help you with that, immutability packages. In Elm, we have an init that inits the initial state. In Redux, we have some initial state, although that's usually a constant and not a function. What else do we have? We have in Elm an update, which takes a message and state and returns state. In Redux, we have something similar called a reducer. The reducer takes an action and state and returns state. And then in Elm, we have messages. In Redux, these are called actions. In Elm, these messages are a type with data. In Redux, these actions are JavaScript objects with a type field. And then finally, in Elm, we have view that returns an HTML message. So this is a mapping from state to HTML message. In Redux, we have components, and these components can read state and can dispatch actions. There's a package for working with Redux in React, and this package is called the React Redux package. This React Redux package adds two things for components. So one, components read state with a new hook called useSelector, and they can get a dispatcher in order to dispatch actions with useDispatch. Those are the basic similarities. The idea is, again, all of your state information is kept tracked in this global, immutable data structure. And the only way that data structure changes is with a reducer. So that's because an action is dispatched, and the reducer will then create a new state. Redux can be kind of complicated, and there's a lot of boilerplate that is often used. Okay, but the minimal amount that's necessary to use Redux is actually fairly simple. But just to give an idea of some of the things that Redux can do, or is commonly done in Redux. So we often will have more than one reducer. If we look at our state information, which we can think of as a tree with some JavaScript object at the top, we may have multiple subtrees within here. So we may have, say, a tree within here and a tree within here. For example, in our state, which is this JavaScript object, we may have one field in here, which is itself a JavaScript object, which contains, let's say, our data. And then we have another field in here, which contains our selection. So information about what's selected and what's not selected. And what we can do then is organize things. If we look at our reducer, it's possible to have a single reducer that is dealing with all possible actions and dealing with all parts of the tree. It's also possible to have our reducer broken up according to the kinds of actions. So we might have a reducer function that's broken up into two smaller functions, one of which deals with one part of the action space and another deals with another part of the action space. And then we can combine them together in a larger reducer. That's one way to cut the reducer. It's by action. Another way to cut the reducer is by state. So we could write a data reducer, and the data reducer would be responsible for all changes over in the blue part of the tree. So all changes in the data part of the state. It would need to handle all actions. Any actions that didn't affect the data part of the state would just return the data part of the state. And then similarly, we would write a selection reducer, and it would be responsible just for updating the things within the selection. And then we could have a combined reducer that combines the data reducer and the selection reducer. I bring this up because as you look at many uses of Redux, you'll see that they often will create multiple reducers. But really the way you need to think about this is just all that really matters to Redux is we have a single reducer eventually that can handle all actions and deals with all updates to the state information. It's possible to extract that out into separate reducers, but there's no particular need. Let's look at an example we will run. So we'll do our counter example, which is a counter example that by counter example, I mean an example showing counters, not a counter example. All right, so let's create a new project. We'll call it test React Redux. That's not what we want because we want this to be a React project. So we'll go test React Redux, take 2. I'm going to do an Npm Install of Redox and React Redux. Of course, an alternate way I could have done this is go put this into package.json and then do an Npm install. Our app is going to become much simpler. We'll start it with that for a moment. And our index.js changes. Our index.js is where we are going to first deal with our initial state. I'm not necessarily going to use the exact scheme that other applications might use. Let me create an initial state. This state is going to be a bunch of counts for counters, and they'll be the values 1, 2, 3. So we should end up with 3 counters, one starting at 1, one starting at 2, one starting at 3. And then this is going to be our reducer. Our reducer is going to get in a state, and it's going to go ahead and in case no state is provided, initialize it to the initial state. It also gets an action. We're going to switch on the action.type because action is going to be a JavaScript object. Here we're going to use a string, and let's just say increment. Then what do we want to do? We want to return a new state. Let's get back to that in just a moment. And then we need a default as well. And we need to return the state unchanged. So here, if we want to do an increment, we need to return a new state. We cannot do something like this. State at action.index plus equals 1. That's just no good because we can't change the state. So the easiest way to do this is use the spread operator. We will take a copy of what's in the state and we will change counts to be equal to, well, let's see, we can't go change the counts directly, so we need a copy of the counts. The spread operator is not going to be a great way to do that. what we'll do is use a map that gets the count and the index. And what will we do? If I is equal to the index, we'll return C plus 1. Otherwise, we'll return C. That's all we really need for a user. So you can see it looks very similar to update in Elm. The only difference is the default here, because the Elm language ensures that we have no missing cases. What else do we do? Well, we need to create a store. This store is going to be this global. We don't want to actually let anyone use it as a global, but it's going to be a global, and we just call create store, and we pass our reducer. And then we have to pass redundantly the initial state. There's no particular good reason for that. Let's import create store. And then the final thing we need to do is do something called a provider. Provider is using some functionality from React that allows a way to provide some information to a subtree of the component hierarchy. In this case, we want the store to be available without having to explicitly pass it to each child in the hierarchy. And so this provider provides a way that's basically going to say the store is available to anything in the app or any of its children. Let me import provider. And then if we go back over to app, what's our app going to do? Let's say we have something like this. And then we are going to map over the counts. But here's my question. How do we get access to the counts? Well, we get that access to the counts using useSelector. So let's do something like this. Const counts equals useSelector. Let's import that. This hook takes a function. The function takes the state and then will return the information that this particular component needs from that state. In our case, what we want is state.counts. Keep in mind, we don't have anything else, but we could have other things. Right now, it's state.counts. And what happens is every time the state changes, every one of these useSelector functions gets reevaluated. And it looks at what gets returned. If what gets returned is the same as the last time, then this particular component doesn't need to re-render. But if this function returns a different value than it did last time, then this component does need to re-render. And of course, when it re-renders, it'll get a new value here. But if this value is unchanged and the props are unchanged, then presumably this component doesn't need to re-render. What are we going to do? We're going to map over the counts, and we're going to take the count and the index, and we are going to return ourselves. Well, let's write ourselves a counter. We've got a variable number of these, so we better have a key. And what else do we have? Let's provide the counts, and let's provide the index. I don't know why it's complaining about index. It says index is not defined. Yeah. And get it right here. Let's write our count. What do we want to do in our counter? Let's just go ahead and return our count. So that'll come in as props, and this will be props.counter at props.index. Theoretically, I guess, we could have not passed in counts here. We could have just passed in the index and then gone ahead and let the counter extract. In fact, let's just do it that way. The count is going to be a useSelector that takes a state, and we're going to take state.counts at props.index. And then we will just display the count. So either one of those will work. You can have a component that chooses to get the information from the state passed down in props, or you can have a component just actually go to the state directly. If this is the case, we are not going to be passing counts in here. just passing an index, and I still don't understand why it doesn't like index. So it's fine with that. I also don't quite understand the indentation. Oh, I see. Of course, I need to specify this as JavaScript, and that looks tons better. And method expression is not a function type. I do not understand what that complaint is. Let's try running this. React Redux doesn't contain. So let's go ahead and add in. It's just trying a new method for imports. And now our complaint is that object is not a function. That's not so handy. Ah, there we go. Okay, we encountered two children with the same key, 5. Oh yeah, that's when I was going and trying to just test this. So let's try this. And we now have our counters, 1, 2, and 3. Let's now update the counters so that we can do increments. We'll have a div with our count in it, let's say, and then we'll put this in a paragraph. And then we'll put in a button. Okay, the button will be here. What will we do when it's on click? Let's come back to that. And a button's going to just say plus. On click, what we want to do is dispatch a. Let's just write a function here. We don't have to write a function, but so our handle button click is going to get an event. And we want to dispatch. So we need the dispatcher. That's where we use the use dispatch hook. With our dispatcher, we just provide an action. So what's our action going to look like? We know we have to have a type, and we know its type needs to match. So this is one piece of software engineering that's often done, which is since this needs to match something in another file, extract these to a JavaScript file that contains the constants. Normally, you'd use something like action types dot increment. That would be defined in a single file that's included both here and over in index.js. That way, we can't accidentally mistype the name of the action type. Because when we're using strings, there's no checking to make sure that this increment matches the other increment. But we're not worrying about that because we really want to learn about Redux and React Redux, and we don't care as much about the software engineering aspects that are orthogonal to the fact of whether we're using Redux or not. Our type is going to be increment. And what else do we need to know? Which one of these suckers are we incrementing? So index is going to be equal props.index. Let's try this. And now all of a sudden we have plus buttons and they work. Let's make one last change. Let's add to our div an onClick to do selection. By the way, another convention in Redux is this code here that actually creates the action object is often extracted into a function as well. So you have action creators. We're not going to do that because it's not strictly necessary. So here, let's do select counter. Okay. So we have button click and we have handle div click. And the reason we do this is so we can make a selection and so that we can later delete one of the counters. So I'm going to add in a couple of buttons here. And here I'm going to just dispatch directly, just to add a counter. And we'll also add a remove. Dispatch is undefined, so we need to use dispatch hook. We will comment out the remove, and let's just try to add. Let's add an add counter. We're going to return a copy of the state with a new count. So the easiest way to do that is, again, use the spread operator with counts And we're going to add in a new count that, let's say, starts at 0. And this is state.counts because we get state coming in as a parameter. Oh, we have a little bit of a problem. Let's look at what the problem is. So the problem is our onClick, right? Our onClick, I'm actually dispatching right now add counter, which is changing the state, which is causing a re-render and so on. We need a function that when you're called will do the dispatching. We add and we get another counter. Let's go ahead and do selection. Here we have select counter, which we didn't write yet. Elm would never have allowed us to get away with that. Here, what we want to turn, copy the state, and we want to change something different. So let's go ahead and say, as well as counts, we can also have selected index. And the selected index is going to be null. If we select a counter, then we want the selected index to be whatever the index is from the action. That looks good. And then back over in app, let's say that we also want the selected index. We don't really want the selected index. We could extract the selected index, but we could actually do a little bit of work here. What we can actually do is do something like this. Count is selected, and we can extract this. So by comparing the selected index against props.index, this will extract exactly what we want. I guess let's just put this in an array because maybe that's simpler. We are extracting out the individual count that we want, and we're extracting out the information of whether we're selected or not, because that's what we really want to know. If we're selected, let's just make the count be bold. So this is working, except our selection, or clicking on things, is not really working. Let's just print out that we're actually getting in there. What's our problem there? Our problem is we are replacing a P with a bold. So I think what we really want to do is have this outside here so that our paragraph tag, I'm not sure why it complains about selected index here. We can certainly get rid of this unused event and that unused event. And it's complaining in the P component, we have a problem. So it thinks we have an object as a child. And the problem is here, I presume. Let's just try. Yes. Of course, this is turning this into an object. We are back in JavaScript mode here, so we didn't need to escape out from JavaScript mode. Here, we need to escape out because this count is within a volt. Okay, so we can select. And now let's do one more thing and let's add the remove. So we're going to go ahead and do a remove counter about remove selected counter. For remove selected counter, let's think about what's the best way to do this. We know the selected index is going to turn into null when we're done. And we know the counts. We should actually remove that particular count. Let's go take a quick look. Let's look at splice. So splice replaces one element, start, delete count, but it does it in place. So let's look at slice, start, end. And it extracts up to, but not including end. what I would recommend we do is duplicate counts and splice starting at the selected index for 1. So we'll delete one item. And so counts will now be new counts. We'll need another dot here. And that's not counts, that's state.counts. Let's see. We select 3 and remove, and it fails. Expected on click listener to be a function, got a value. Let's look at that. And again, I failed to make a Lambda function for this. We're going to have to go look and see what that is. Oh, actually, I know what that is. So remove selected got called, and yet there was no selected index. It was null, so splice must be doing something like that. This is where we need to actually check the current state beforehand. So here we really want to say if state.selectedIndex is greater than 0 and less than the length of the counts array, then this is what we want to do. So basically, if the selected index is valid, that's what we do. Otherwise, we just want to return state. It was an invalid action, and so we're going to return our existing state. Let's go back and try this. And now remove does nothing. Now we'll talk about the UI for that in a moment, but let's select, let's say that one and remove. And the first one is not working. Let's just see why. Let's say A equals 1, 2. And let's say A dot splice of 0, 1. Then that leaves 2. A dot splice. Why is it's not working yet? Well, it must be our value here because we have a greater than and not greater than or equal to. And so the last thing that we want to do is just update the button here not to display it is not selected. What we want is counts and has selection. So our function is going to return state.counts and we'll return the state.selected index not equal null. And we'll close the array. Now we'll only display that button if we have a selection. And that looks good. Maybe when we add, we want to turn off the selection. So that's something where having all of the state information in one place is really handy. So we have a reducer that can decide, and based on an action, the global state of everything. So in this case, we're adding a counter. We want to go ahead and set the selected index to null. That's what we said. And now when we add, it deselects. That is our quick introduction to a minimal amount of Redux and how that's used with React. But I want you to keep in mind as you go look at how Redux is actually used, is it's actually used when you have a fairly large application. You've also got a large number of actions and a large amount of state. And so there's a lot of software engineering techniques that are used, basically trying to not repeat yourself. So the dry principle, don't repeat yourself, is used to ensure that we don't have problems. But what that will lead to is a lot of what looks like boilerplate code around. We didn't happen to see that here.